In the trie data structure class, we have moved a copy of the addString function as a private method. Furthermore, in public, we've just called addString root the word that's being passed with constant call by reference, and we start at character 0, just like we did in the trie node test. What we're going to be doing now is contains. The public method takes in the string and it's called with a const, and we call the root, the word, and character 0, very similarly to how we did addString. When we go to contains, we see that we're not calling by reference because we don't plan on making any changes to the pointer. So here's what happens. If the value, this current unsigned int value, is less than word size, that means we haven't reached the end of the word that we're checking. So what we're going to do for simplicity is, again, we're going to create a pointer next level, which is equal to the address of the specific trie node pointer. We want to get that specific trie node by casting the character from ASCII to an unsigned integer to get the location. That particular node next level is dereferenced, and we check the valid letter. If it's true, then we're going to recursively call and check the next letter, and we do the check of the next letter by doing value plus 1. The next level will be the child. If this isn't true, then we now know that this particular character at this location is not in the trie. Therefore, this is not a valid word, and we return false. The last case you coded up is what happens if we've reached the end of the word. So if we haven't reached the end of the word, we say, here's the if statement. I have else if commented out, but it's logically equivalent because this is the only other case we can reach. So here, if we reach the end of the word, then the last thing we need to do is check to see if it contains the wildcard character star. We cast the star to an unsigned int to get its location in the array. If that's true, that means that we have found a valid word and we return true. In this case, then it will return here to the public method and it will work. So now I'm going to run make clean, clear, and then make try test. And in this example, I print out the level order traversal of the Batman trie, and then I do several tests. We see BA is not in the tree. We have a B and an A, but we see that T is below it, but the star is equal to false. So therefore, we'll know that BA is not in the trie. We see that Bat is, Batman is not, which is what we want. And all of these passed our tests. Riddler is not in the tree, Bat Computer is in the tree. And if we were to go through this, we would see that Bat Computer is. I also take a subset of the word bat comp, which is not inserted, to test. It'll go through and it'll get to bat comp. And what will happen at this particular level is now it will get to the end. So we've reached the end and it will check to see if we have a valid character. In this case, I have not put in a star because we didn't put in bat comp. Therefore, this will be false and it does not have any children, which is why it tells us successfully that this is not in the trie.